Okay, so today we will kind of look back to our fitting of linear model. As you recall, it looked like this, fitting a line to some data points, and today we will fit a second order polynomial to data points. So for that, let's save this file with, let's put least squares 4 and to today's lecture folder. All right, and now least squares fit of a quadratic model. Second order polynomial. Yeps. March, April. Okay, so let's keep the plotting parameters. Maybe let's keep the same data just for the time being as well. So we have some time points from 1 to 7. We organize them as a vertical vector. We have the corresponding measurement points, M1 from M to M7. Let's organize them as a vertical vector as well. Let's keep the plotting of the measurement part as well. And then let's construct the least squares fit to the data. So now we use a different model. So we actually use plus b t. Maybe I'll just write it like this, so it's not confused with MATLAB notation. A and B and C are our unknowns. And matrix equation should look like this. Okay, and then in this case we actually have here T1 squared the time points squared up here in this matrix. Like this, and right hand side vector. So we have just V. We solve in the least square sense, and this time we have a third number as well. And now actually I think we will need some more points. And here also we need this one squared, and here we need this dot, so it means that every element in this vector is squared. So this is not a matrix power, but this is a pointwise squaring of the elements in the t vector. We have b times t plot plus c. And let's see what happens with these modifications. Okay, so now we have a plot like this, and as you can see, there are kind of jagged edges here in the plot. So this doesn't really look like a parabola. This looks like a set of linear segments, and that is because when we plot, so these are the points where we plot. I have only 5 points. This is way too little. I mean, for a linear function 2 would be enough because it's just a line. But here let's have a few more points. I think our plot will look more beautiful. So now maybe it's more like a smoother parabola. Maybe we could also change our points a little bit so that we can get a more curved. For example, let's take these last 2 points more down, so maybe we see the parabola changing shape. So our last 2 points, I don't know, let's put here 1 and 0.5, and let's see what happens. So now the parabola has to take a very different shape to better follow the data points. Okay, so what do you think?